Hello everyone. In today's session, let's talk about introduction to Docker Engine 2. Before that, I just want to give a quick introduction of what are the container tools we have as part of open source and then enterprise. We have a tool like LXC, which stands for Linux Contain. Before Docker and other tools came into existence and used by many of the organizations, we have this containerized technology earlier as well, but it is restricted to only Linux operating system. That's the reason why many of the organizations have not adopted this particular tool to create a containers and run their applications. After that, we have a tools like Creo, Rocket Linux, and then Containerd, Docker. Under the Docker, we have Docker Engine tool and Docker Desktop. If you want to go for open source, then we have to pick Docker Engine. If you want to go for enterprise, then we have to go for Docker Desktop. And then we have Podman. Podman is all about you can launch containers and we can spin up the pods as well, which is a concept of Kubernetes. That's the reason why it is called as Podman, Pod Manager. This is also one of the widely used tools by many of the organizations in the recent times, and then followed by Runc. Now, these are the tools which are used by many of the organizations to run their applications in containerized platform. Now, let us discuss why we have to go for Docker Engine, though we have these many tools. First of all, Docker Engine is a OS level virtualization as we discussed earlier as well. For what? To deliver the software. It is an application software in the form of packages, which is called as container. So what your container has, let us try to recall once again. The container will have your application software related libraries and binaries so that we can run our application inside it as part of OS level virtualization. Now this Docker engine is an open source where I can install on any operating system and I can spin up my containers without purchasing any subscription. That is the advantage what we have. And Docker engine was initially released in March 20, 2013 as part of Apache 2.0 license. And this particular Docker engine was developed by using Go language. Not only that, it helps us to deploy the application in lightweight container. When your container is lightweight, we can run this particular application on different environments. Why? Because it will consume less amount of resources on the platform. And this container will share the services of a single operating system kernel. As we talked earlier, in the what is container, the operating system kernel will be common for all the containers running on that particular Docker engine. Now, when you compare with virtual machines, it will consume less amount of resources. Why? Because it is lightweight. When it is lightweight, it will consume only the less resources what is needed to run your application inside the container. Whereas in virtual machine, it will consume the resources for your operating system kernel and then your application. So your application is not at all using the entire resources what we have allocated to the virtual machine. Few amount of resource is consumed by your operating system kernel and then followed by application. But in the containerization technology, the entire resource what is allocated to the container will be used by your application. And it will use the resource only what is necessary. And based on the requirement, it will allocate the resource to your container by the Docker engine, which is a dynamic process. In the virtual machine, the resource allocation is static. If you want to modify the resource, you have to have a downtime. But in the container platform, we no need to have a downtime. Everything will be controlled by Docker engine. That is the advantage what we have and why we are going for Docker engine tool. Not only that, Docker engine uses underlying technology called Linux kernel namespaces and C groups, which is a major technology why Docker has been adopted by many of the organizations to run their containers. Because to isolate your containers on the Docker engine, it uses a concept of namespaces and C groups. C group stands for control groups. It will control the resources what is allocated to the container. Let us say if the container is supposed to use only 1 GB of RAM, your container cannot cross beyond that 1 GB what is allocated. This entire things will be managed by C groups, for example. And the namespaces, we have totally 7 types of namespaces. And for every container, it will try to create a namespaces of all these 7. And these namespaces are isolated so that one container namespaces cannot talk to another container namespaces, though they are running on the same operating system kernel. That is the advantage what we have and what Docker engine will use with the underlying concept to create a containers. Further, Docker provides a tools like Docker is a community. In the Docker, it provides a different tools like Docker engine, which we can call it as open source or community edition. Everybody can install this Docker engine on your Linux operating system or Mac or Windows. And then if you want to go for subscription, like a paid version, then we have Docker Desktop, which is a GUI model, graphical user interface. Not only that, if you purchase a subscription, or you can go for free as well, even for Docker Desktop. Docker Desktop I can install on Mac as a GUI or in Windows operating system. Now it is also supported in Linux operating system desktop version as well. You might have know about it, or else Linux has 2 types of operating systems. One is desktop and one is server edition. If you are going for server edition, I would say you have to go for Docker engine. If you are going for desktop version, we can use Docker Desktop as well as part of GUI. And then we have Docker Compose, which is an orchestration tool to manage your resources on the Docker engine or on the Docker Desktop. And then we have registry. Docker provides its own registry called Docker Hub, where we can pull the images from that particular registry and we can spin up the containers. Or if you want to maintain your own private repository, we can do that as well by creating an account in Docker Hub without looking for any third-party services. And not only that, it provides many other tools as well, but these are the major tools what we use as part of Docker. Docker engine was built on top of containerd. Your Docker is not actually creating a containers. Docker is using underlyingly a runtime called containerd, which is a CNCF project, Cloud Native Computing Foundation. Under that particular project, we have a tool called containerd. So Docker engine is using containerd to spin up the containers in the backend. So from this, what we understood, Docker engine is like a wrapper. It uses backend different technologies to collaborate them together and to create a solution for you. That's what your Docker engine will do in the backend, like kernel namespaces, C groups, containerd. These are the underlying concepts of your container creation process. Not only that, in June 2015, Docker donated this container image specifications and the runtime code to the OCI, Open Container Initiative. And why we have given like that? Because everybody can follow some standardized rules and regulations so that everybody can develop their images with the same specifications. If you develop a tool, if I follow the same specifications, I don't need to understand the concept of a new tool. I can build the images with the same underlying concept. That is the advantage what we have. That's the reason Docker donated this container image specifications and runtime, which is called as runc, to the OCI, which is called as Open Container Initiative. After understanding all these particular points, now let's see the architecture of Docker engine. In this, we have totally 3 concepts. Let us divide this diagram into 3 portions. One is a client, and we can see Docker host. We can also call it as Docker server. And then we have registry. In this registry, we will have images. Someone will upload the images into this registry as a public so that everybody can download. You don't need to have a permission to download this particular images. Those are called as public images. If the images are private, you cannot authenticate and you cannot download. That is a secondary thing. But all the images will be available under Docker Hub registry. Now, this is your system. In your system, when you try to install Docker Engine, client and server both will be installed on the same system, which is called as Docker and which is called as Docker D. Docker D in the sense Docker daemon. You can see here. So from the client, we will execute some particular command. That command will send a request to the Docker daemon. If both are running on the same system, how my request will be sent to this particular daemon? By using sockets. By default, it will use Unix socket. So this Unix socket will transfer the data from my client to the daemon. By using which socket? By default, it is Unix socket. The communication will happen within the system if I use Unix socket. For example, you have a requirement where I want to run this particular client on one machine and this particular server on another machine. We can do that. At the time, we can't use Unix socket. So what we have to use? TCP socket. At the time, we have to use TCP socket. Now, if your client is running on one system and if your daemon is running on another system, they too can talk to each other. But we need a network like this. And we need to have some port number. The first port number, what you're saying is 2375. It will transfer the data in unencrypted format. But if you want to transfer the data over encryption, then we have to use 2376 port number. Anyway, this is all about communication between the client and the Docker server. And we also have another protocol called FD. If you want to communicate to your Docker daemon from the CLI by using systemd, then we have to go for FD. So these are the three types of sockets that we have in order to establish a communication from the client to the server. Now, once my request has been sent to the server, what it does? It all depends upon the request what you try to execute. For example, I'm trying to launch a container by executing this command. I sent a request. My Docker daemon will see I passed some image to create a container. That image is not available in the system. So what it does, it will contact your Docker Hub. It will search for the image. If it is available, it will download. After the image was downloaded like this, and then it will start creating a container. When you execute this command, you will pass some image. If that image is not available in the system, then it will try to download from the Docker Hub by default, and then it will start creating a container. Now my requirement is I don't want to launch a container. I want to download an image. Now when I run this command, this request will send to the Docker daemon that I want to pull an image, some X image. Now it will see whether the image already exists on your system or not. If it is not available, it will go to that Docker Hub by default, and then it will search for that image. If it is available, it will download. Technically, in a registry, the image is called as a repository. So it will search for that repository. If it is available, it will download. It will not launch a container. Why? Because you are executing this command, Docker pull. For example, you want to customize the image and you want to build your own image. Then we execute this command. For this command, you need to write a Docker file. From the Docker file, it will build an image, your custom image, whatever you want. And from that custom image, we can launch a container. So there are multiple approaches. To create a container from the image, we have multiple approaches. Either we can use a public images, or if you don't want to use a public image, you can create your own image. That we will see in the practical sessions. For now, this is the basic architecture of Docker Engine. I hope this is clear. That's all for this particular topic. Thank you.